Hi, my name is Martin Krzyżanowski and I'd like to welcome you on the next tutorial from InstalSystem 5 package. In this video, I would like to show you how to design heating installation with convective radiators in InstalSystem 5 package. I will take you through all stages of the project design, and as the final result, I would like to obtain that kind of installation in our project. Now on the screen you can see one of our standard project files. You have access to this example directly from our help system platform. Access to help system platform you have directly from our InstalSystem 5 manager. If you click on help button, there you will find 3 tabs: technical support, online help, and video tutorials. And if you click on this one, online help, you will see our help system. And in this list of articles, in this group sample projects, there you will find convective heating installation with risers, and this is the project file you could see, this one. But also above you will find designing heating systems with convective radiators. And that's the lesson I will show you today, with all stages to obtain finally the drawings and the complete results of heating installation. This is accessed directly from our InstalSystem 5 manager, but if you use just browser, web browser, you should just type in InstalSoft help system, and also this way you will find our platform. By default, probably it will be opened in the Polish version, but you can choose English one in the left bar. So, as you could see, we have many radiators in this project. We've got few risers, and we will start the project with the first step, with the first phase, what we usually do when we create new project. So we will start with setting general data for the project. Before we will start our designing work, this existing installation will be deleted, but I will leave it now to explain you some settings of general data and their impact on the results. So first we will change screen arrangement to general data, and we'll check some tabs. First, we need to check if we have access to the proper project scope. Heating systems, this checkbox should be on, and generally if you want to have access to this heating system scope, you need to have in your configuration proper modules. And we are back again to our InstalSystem 5 manager. There. And on this tab, you will see the list of modules available in your configuration. And we need heating systems, and also we need radiator sizing. These two modules are essential to have a possibility to design heating installations with radiators. The next tab, catalogs. There you will find all products, all databases that are available in your program, and we can limit that list to radiators. And now you can see two producers, two databases available in this English version, and also in this window on the right side you will find some neutral database of radiators. This one was prepared by us and it covers quite big range of radiators types, starting from some typical steel panel radiators to some decorative radiators. So you will see it in the project when we will be selecting some radiators in different locations. And just to compare, you will see now the list of databases available in Polish version. So you may see that there are much more different manufacturers in this version. And generally, depending on language version you use, you will see different scope of databases. And if you use your favorite producer, or there is some popular producer on your market, and you would like to have these databases in the software, please contact that producer and ask them to contact us. Our contact data you will find on our webpage, InstalSoft.com, and there is contact data tab. There is email address and phone numbers, and we'll try to supplement the program with more databases. Next tab, we may go to storage management, and there you will see list of levels in our project. We have basement, ground floor, first floor, second and third floor, and attic. And we will design that installation on these 3 floors, first, second, and third. And we will draw distribution network in the basement. On this tab, mostly these 2 parameters are interesting for us. As you can read below in this table, this is distance of pipe runs from the floor. This value means that the pipes will be inside or below the surface of the floor. We go to the next tab, sources, and there are 2 major parameters, supply temperature and default temperature drop on radiators. Next group of tabs, distribution system, and let's take this one, types and default data. There you select the system of pipes and fittings that will be used as a distribution network in our project. And there you can see we have some multi-layer pipe, and you can choose different type of pipe for these different locations in the project. We've got 4 different locations: branch, radiator circuit pipe, building unit, riser, and network. And as in this case, we have the same pipe in all these locations, but sometimes in different projects, for example, you may use different pipe in the network in the basement, or different material of the pipe on the risers. Using these settings, you can do it for the whole project by setting general data, but you can also do it directly for some selected pipes. And let's go back to a drawing now, and let's take a look on one of the apartments. Now you can see radiators, and if you select this pipe, this is the last one connecting radiator with the network, you will find in a data table location and you can see that it's been automatically detected by the program as connection line radiator circuit pipe. So this computer symbol indicates that this selection has been done automatically by the program. If we click on the next pipe, you will see that this is building unit. And now if we use 3D view and select one of these vertical pipes, you can see that this is riser. And finally, in the basement, if we click on any of these pipes, it's been detected as network. So, as you can see, program automatically divides the whole installation on some sections or some locations. And if it's required using this general data, you can set different materials or different pipes for these locations, or you can do it directly in the editor just by clicking on some pipe and changing location. On the right side, we can choose insulation for the pipe, and in the next column, we can set ambient temperature of the pipes in different locations. And this value, this temperature, has impact on temperature drop in particular sections of the pipe runs. What is a temperature drop? We can check in a hint. You can see the last value, decrease of temperature of medium in pipe run. The next setting is right here. With this setting, you have influence on the list of materials. If program detects somewhere in the installation connection of 4 pipes, choosing the proper variant from this list, you choose if in this situation program should determine and list in the bill of materials 2 teeth or cross piece. The next group of settings of fields below consider some valves, typical valves we have on the installation, like differential pressure controller, partner valve, three-way valve, but this one will not be used in our installation, it's rather for radiant systems, non-return valve, and other valves like ball valves or shuttle valves. And also in this list you can use our neutral catalogs, or you can go back to catalogs window and, for example, this time we can check what valve producers are available in this English version. And we could import one of these catalogs, go back and change this selection. Below we've got also default types of fittings and manifolds. And on the right side we've got few parameters that influence on the balancing of the installation. Minimum pressure drop on regulating valve and minimum pressure drop on differential pressure valve. The next tab, pipe and insulation sizing options. There you can see the default pipe. You can see the next pipe. And finally, we can see some parameters which we can change to have impact on diameters sized by the program. So minimum internal diameter of the pipe, maximum velocity, and maximum unit pressure loss. And there in this list you can see what diameters are available for selected pipe. If any of these diameters shouldn't be taken into calculations, you may uncheck it, and you may also decide if on some change of direction in the drawing, program should determine just bends or elbows. The next step is common for radiators and radiator valves, and there you may select different types of radiators and their connections and fittings. In the first group we have some settings for radiators without valve inside. So in the first column on the left side we have radiator type, and we can set different for typical radiator, and below for the bathroom radiator. On the right side we can choose some set of connections from the catalog we use in our project. So the catalog we chose right here by choosing the pipe from the list. And we can choose different set of connections for the standard radiator and for the bathroom radiator. And in the last column on the right side we can choose also some default valves on the supply pipe and on return pipe. Below we have similar group of settings for integrated radiator, and also, as you can see with these icons on the left side, we have 3 variants of radiators depending on the location of connecting points on the right side, on the left side, and central connection. There we can choose similarly connection set and proper block to connect radiator to installation, and same for bathroom radiator. And looking at these settings, mostly on these two settings must correspond. If you choose floor side connection, you should also choose here straight valve. If you choose wall side connection, you should choose angle valve. Let's analyze it in our project. Let's take our 3D view and change a little bit configuration to see just one level, and let's take one of radiators. Okay, maybe this one. In this situation we have some typical radiator with integrated valve insert, and there's a block. And if you select that radiator, you will see terminal unit connection system floor side, and below integrated radiator coupling, also straight one. And let's change it a little bit. This time I will choose wall side connection, but I will leave that straight valve. And let's calculate this project. And after calculations, let's take a look into our diagnostics window. Now you will find in the list one warning. Terminal unit connections not sized. Wrong valve. And if you make a double click on it, program will select that radiator. Because I changed that connection type, program expects to connect this radiator from the wall, but finds that valve with straight connection. So the program cannot size proper fittings to connect it, and that's why you can see that message. And also you will not find list of fittings used to connect that radiator. There is the text not sized. If we change it properly back to floor side and calculate it again, and now check it again, now you can see two fittings in the connections that are used to connect directly this pipe to this block below the radiator. So, summarizing, you should pay attention to these two settings: connection and the valve. Shape of the valve should correspond to selected side of connection. The last group of settings here, common settings: minimum pressure drop on thermostatic valve and on return valve. And there also we can set what should be the distance of the radiator from the wall, separately for bathroom radiators and for other radiators. Okay, so now we go to the next tab, radiator sizing options. And on this tab we can define the method of determine the size of the radiator separately for each dimension. So for the height, length and depth of radiator. Default method is fit to recess, so to fit under the window. And we've got two other options for each dimension: user specified or smallest from range. And let's take a look again on our example and radiator. As you can see, this radiator is located under the window. There is no recess, so it's exactly on the wall. And because of this default method, which you can also find by selecting particular radiator in your project, the size of this radiator has been determined to fill that space under the window. And in the project you can find two different situations, like this one. There is no recess and the radiator is exactly on the wall. But we can also put here recess and move that radiator inside recess. So let's do it now. Let's find that radiator on the plan view. It's right here. We can also divide the screen into two parts to see 3D view and 2D view. And now using construction tab, I will use this icon and put recess under this window. You can see it on 3D view, and we need to change the size of this recess, maybe 1 meter and 0.8 height of it, or even less, 0.7. And now I will move that radiator to have it in the recess. So like this. And now when you rotate 3D view, you will see the difference. And now if we calculate the project again, we should see different result of sizing this radiator. Now you can see that it's smaller because program uses this method to recess. This is the maximum value taken from the drawing, height of the recess, and there is also some additional size required to mount this radiator. For example, to connect this block from below. If we change this method to another one, like for example, smallest from range, there you can see some maximum value. Let's set it to 800 millimeters. In this case, after calculations or during calculations, program will check what heights are available in the catalog and will choose the lowest one. And now we can see the difference. Maybe the height is the same, but we've got longer radiator. So by controlling these settings separately for each dimension, you have complete control on the rules according to which program size the radiators. And now we will go back to general data, and let's focus now on the right side radiator sizing options. Few settings right here. Maybe let's start with this one because they are easy to be explained. Additions for radiator size. Some additional percentage to radiator size because of placing the radiator not under the window, or mounting thermostat, or just taking into account some other parameters. There we can also control the scope of radiators taken into account during sizing, during calculations. Some producers mark in their catalogs what variants, what sizes of radiators are standardly available and which should be ordered separately. So by changing this setting, we can define in what scope of variants available in the catalog. Program will try to find the proper one, the best fitting size of radiator. And on the top of this column, we have a few more settings. Resize radiators after calculations. So if the radiators are sized and you don't want the program to change their size after calculations, you can uncheck it. Retain user-specified radiators. So if we choose directly in the drawing, when you select any of these radiators, you have access to data table and you can just choose manually type of the radiator and size of it. And if you do it, and if you leave that checkbox on, program will stick to it, still stick to this selection. And finally, we've got that function, adjust flow rates, and it's quite interesting and useful function and I would like to explain it more precisely. To analyze influence of this function on the results, let's first uncheck it and calculate the project. And let's check results first on the drawing. Again, we will use the same radiator. And if you check now results of heating output, you will see required heating output it's 589 and obtained heating output is 186. So almost exactly we've managed to cover heat demand, but if we check results of other radiators, there is a tab list of rooms heating. In the last column you will see in percentage coverage of required heating output. And you can see in all cases this is not exactly 100%. It's a little more or a little less than 100%. We can also see some warnings in diagnostics window below. So it means that the output generated by radiators is a little too high or a little too low. And we now come to the point. When this checkbox adjust flow rates is off, during calculations, program tries to maintain that temperature drop of 20 kelvins on each radiator. The size is taken from the catalog, and then the flow is determined to obtain that value of temperature drop. If this checkbox is on, program adjusts flow rates to obtain exactly 100% coverage of required heating output. And now if we take a look again on the results on the same table, you will see in the last column in most of the cases, in most of radiators, exactly 100% coverage of required heating output. So when this checkbox is on, temperature drop on the radiator will not be equal to this value of default 20 kelvins. It may be less or more, but in return program will be the radiator will be better sized, and this output will be exactly equal to the value required. And we can also see it in these two columns. When you design new installation, impact of this function may not be so significant because, as you could see, the coverage was between 90 and 100%. But let's imagine now that we don't design the new installation, but we deal with the building that is thermo renovated. So let's imagine that this is standard situation, that the walls are insulated, the roof is insulated, and the installation is partly replaced. Because of additional insulation of the wall, the heat demand goes down, so it's reduced. And usually in scope of installation, the part of installation in the basement is replaced with new pipes and new balancing valves and new insulation. Usually also valves, thermostatic valves on radiators are also replaced, but radiators stays. They are not replaced. And in this case, if the heat demand goes down and we don't change radiators, not to have overheated rooms, we should either reduce supply temperature or reduce flows through all radiators. And especially in this case, this function is very useful because if the heat demand of the room is reduced and we don't change the size of radiator, program adjusts the flow to reduce the output produced from radiator. So usually in this case, instead of 20 kelvins temperature drop on radiator, we may obtain 30, 35, for example. So in result, program reduces the flow through radiator and in this way also reduces the output produced by radiator. Without this function, without possibility using it in calculations, program would keep default value of 20 kelvins of temperature drop. And after calculations in mass of the cases, in mass of radiators, we would receive message informing us about too high output produced by, by radiators after building thermal renovation. And I think these are all data we need to check or we need to change in general data. We may skip other tabs and we can go to the next phase of the project. We can go to graphical edition of the installation. Okay, so this existing installation you could see in this project has been deleted. And let's take a look now on plan view. This is first floor. And you can see that there are 4 apartments, first, second, third, and the fourth one. And we will just focus on one of the apartments and we will take that one and design installation just in this apartment. And then we will copy it on the next levels and draw the installation in the basement. And in the final result, you will see also remaining part of installation. So let's take a look here. There is antechamber, there's kitchen, living room, bathroom, and room. First, we need to choose proper edit scope, convectional, and on the ribbon you will find icons and elements that can be used to create that installation. So first we've got a group of icons, distribution thermal installations with pipes, source. Flat stations are available if you have that module in your configuration. Riser to connect part of the installations on many levels. mixer or pump unit, manifolds, double or single bars, valves, other fittings, and another group convectional with terminal unit. This is some common element which can simulate any receptor in cooling or heating installation. Radiator valves, and finally radiators. And if we design installation on entire level, we could use one of these icons to quickly insert radiators under each external window. For example, if I click right here, you will see under each window radiator. But as I said, we will just focus on part of this story, only on one apartment, so we will just put the radiators manually using one of these icons. And I will choose that one, integrated radiator right side connection. And let's start maybe with living room. Next, kitchen. Next, this room. And finally, we have bathroom, but instead of this default steel panel radiator, I will use bathroom radiator. And I will put it on this wall. You can see it in a quite big distance from the wall, so let's delete it and let's open again general data and change this default distance from wall to 3 centimeters. And now if we repeat that operation, you will see it on the wall. So we have 4 radiators, and now let's put somewhere a riser which will connect this installation supplying these radiators with the other part of installation in the basement. And I will put the riser simply just there, assign some symbol, rotate it, change the spacing between the pipes, and I will put it inside this wall. And this riser should start in the basement, so it goes from the basement to the first floor now, and later we will extend it to other levels above. And now we need to just draw distribution pipes to connect all radiators, and I will do it just like this. There and there. Starting from these points, I create these and go right there. And finally, I will connect this bathroom radiator. Okay. And as you can see, these two radiators on the left side, they are not connected. And we will use one of the functions that automatically connects radiators to the pipes. It's available right here. Automatically connect terminal units. To use this function, we need to select these two radiators and the pipes to which these radiators should be connected. You can do it quickly by selecting some fragment of the screen, two pipes and two radiators, and click on this function. These two radiators have been connected. These two remaining parts of the pipes are highlighted in yellow, and we can just click or press delete to delete these two parts. So all these four radiators have been connected, and let's go down now to the basement, and let's put somewhere source, and let's connect this single riser with the source. Let's say that there we have boiler room, and we will just put there a source and simply connect it with the riser. Just like that. I will go back to general data to check also on storage management tab what is default value of pipes distance from the floor, and it's fine. It's set to 2 meters and 20 centimeters, so it means that the pipes are not on the floor or below the floor, but they are close to the ceiling. And before we start calculations, we may check the connections. There is some extra icon. If you click on it, program will check connections between items of the installation. If this yellow window is empty, it means that the flow and the connections have been detected by the program. You can see also these arrows in the middle of each section. And now let's analyze this installation on 3D view. We may hide other levels, just leave the first floor, ground floor, and the basement. And there is that installation. You can see radiators. And here we can see this bathroom radiator. As you can see, this radiator, its distance from the floor is the same as for the standard radiators, and we can change it by editing data of this particular radiator. First of all, let's increase distance from the floor to, let's say, 0.6. It goes up. And we also need to change these restrictions in scope of dimensions, because this default method can be applied for standard radiators under Windows, but it cannot be applied for this kind of bathroom radiator. So instead of this default method, I choose smallest from range and change the values from 0 to 2000 millimeters, and same for length, let's say to 1 meter. We also don't have, for that moment, valves, thermostatic valves on the pipes connecting this radiator, but I will leave it for the moment. First, we will calculate the project. We will check the radiators, the flow through this radiator will be unbalanced, and we will see the message about it. But first, let's try to calculate it, and let's see what we will receive after calculations. So I will save this project. And calculate it. Okay, it's been calculated. No errors because there is no red color under this icon, but there is yellow color, which means that there are some warnings. Let's check them. And as I mentioned, we've got information about unbalanced flow because there is no any valve that could regulate flow through this radiator. And there's also one information about connections with the source. The fittings that connects the pipes to a source were not sized because program at this stage has no information about threads or generally about diameters of these connections. We can easily change it by clicking on a source and just choosing from the list proper threads. Let's say that this is 1 inch. Okay. And let's take a look on our 3D view. And I will display also construction to see this radiator, this bathroom radiator on the wall. And now you can see that these pipes doesn't look well. They should rather come out from the wall, not from the floor. And that's what I would like to do now. But again, maybe let's change the view a little bit. We will hide all walls. Just like that. And just display this one. Okay, and let's imagine that I would like to change layout of these pipes. First, let me check that radiator. Wall side connection is fine. And now I would like to move that pipes higher. Now they are in the floor, and I would like them have somewhere little below the radiator. So they should come out from the wall on the proper elevation. How to do it? First, I need to divide the sections using this icon and this point. I will put it on a supply pipe and then also on return pipe. And if you click on that section, you will see some gray labels. They are inactive, so we cannot edit them, but we can see in these labels the values. The one above, this is elevation of this section from the ground, from point 0, and the next one is distance from the floor. On the right side, you can see elevation of this connection point to radiator, and it's 0.6 from the floor. So, because I want to have this section just a little below the bottom of this radiator, I will change in a data table distance from floor to 0.5, and same I will do with this supply pipe. And now let's check it on 3D view. Now it goes up. Let's display construction. And now we can see also wall. So that's what I wanted to obtain. I have just these pipes coming out from the radiator and going into the wall. And finally, we may also put on 3D or 2D view valves. The first one on supply pipe and the next one on return pipe. And now, after calculations, we can also, before we can rotate that valve, and after calculations, flow through this radiator should be balanced. We don't see this message about unbalanced flow anymore. So it means that all radiators were sized, and this installation has been also hydraulically balanced. And let's check result of one of these radiators. We can see it in a hint. And you can find here all information about size of this radiator, about flows, supply temperature, return temperature, about connections, valve setting, and also about this connection set that is below the radiator. And same we may check results of this bathroom radiator. You can see that there are more fittings required to connect this radiator, probably because of thread of the connection points. And let's take a look also into result tables. The first one, general results heating, and there is common information about heat losses of all the rooms. We can see supply and return temperature, total output from these 4 radiators, and more parameters about the pressure and flow. And for example, we can also check a list of pipes, fittings, and couplings. And the list of radiators. So, as you could see, we could very quickly design this small installation, and in the next phase we will copy this installation on the next levels. If we couldn't copy the installation, we should just go to a plan view, select the riser, and extend it on the next level or levels if the installation on next level should be connected to the same riser. But in our case, we can copy that part of installation we've just prepared, and we can do it very quickly. Just with mouse we can select all items of the seating installation on this first floor with the riser itself, and in this group of icons we have some arrows up and down. The first one as you can read, copy selected elements of a story above. So when I click on it, it will be copied on the second floor, and if I do it again, it will be copied on the third floor, and I may check it now on 3D view. As you can see, all elements, radiators, pipes, and valves have been copied, and the riser has been extended to next levels. So let's recalculate the project to refresh results. And in the next phase, I would like to show you how you can balance installation. But before we do it, in the meantime, I will complete installation for other apartments. So we will have 4 risers, and I will show you what types of balancing valves, or what valves generally we can use in the program to balance hydraulically the installation. Okay, so I have completed installation on the first floor. This was the first apartment we did, and I supplemented other apartments with radiators. So we've got 4 risers in the corners of this corridor. And these 4 risers supply all radiators in all rooms. And then I copied that installation on other levels, so it looks exactly the same. And we can also see it on 3D view. And now we may check if the installation is balanced hydraulically, and we may also add more valves on the risers or in the basement. If we check the diagnostics window, there are no any messages about unbalanced flow. So it means that using just thermostatic valves on the radiators, it was possible to balance all flows through radiators. But it's worth to use some balancing valves on the risers, because it will improve working parameters of these thermostatic valves. So maybe let's first check one of the radiators, maybe this one. And you can see in the hint setting of this valve insert, you can see pressure drop. And using this 3D view, we can also display here critical route. Critical route, this is a route with the highest pressure loss. So starting from the source to one of the radiators. And if we would like to add some balancing valves, or maybe differential pressure controller, we can use 2D view or 3D view. And maybe let's check, or let's take just that riser first, and let's put single valve on return pipe. And in the data table, we can check what valve types we have in this our neutral valves catalog. There are different groups of valves, and here we need balancing and regulation valves. And we can choose one of them from the list. This is our neutral valves catalog, so you can see some quite wide scope of types of valves. Depending on what manufacturer you will use, you will see different contents of these databases. And let's choose one of these valves. If you choose this variant, size program will determine proper diameter and setting. And because this is not any particular valve from offer from one of the producers, instead of giving setting, program presents expected kV value. And you will also find it in a hint. This hint also presents required fittings to connect this pipe in a riser with this valve. So you can see some reduction and some nipple. And this is just balancing valve, and that's used on another riser pair of valves. There we will use differential pressure controller. When you click on this icon, first you may click on, for example, return pipe, and next on supply pipe. And because we have first checked or introduced some default valve types in general data window, we don't have to do it directly on the drawing. And we may just calculate this project. And let's take a look on the plan view, on the basement. And there you can also see what should be the scope or the range of stabilized pressure for this particular pressure controller. And if there are settings on that valve that creates pair for this differential pressure controller, what should be kV value of this setting? And just to have another solution in our project, let's use on the next riser another type of valve. There we will use this pressure independent balancing control valve. Okay, and again you can see setting in liters per hour and pressure drop. And finally we may take the last riser and also use there one of previously used valves, types of valves, and I will just use there some standard balancing valve. Okay, so the whole installation is hydraulically balanced. If you want to see more details, you can check result tables. Maybe starting with this one, heating terminal units. In this list, you will find all radiators with all their parameters, and below each radiator you will find also valves and other fittings used to connect them and to balance flow through this radiator, so you can analyze these results in cooperation with 2D or 3D view. You can check very precisely each pipe run, each section with all parameters of the section. If there is any valve or any other fitting, you will find also information about it in this table, like in this case thermostatic valve. And finally there is a page or tab, heating cooling circuits, and on this tab you can analyze all circuits starting from the source to each radiator, and there you may check section by section results, and if on any of the pipes on the route from the source to particular radiator you find some dubious results, you can check it. You can, for example, display this section in the drawing, and this way you can very precisely in details analyze all the results. And finally we've got list of materials, much more items than we had previously when we had just that simple installation in one apartment. List of installation, valves and fittings, and a list of radiators. Okay, so we have plan views, we have 3D view, and now in the next phase I would like to generate schematic views of this installation. So we have in our project plan views, which later can be printed or exported to DWG file. We have 3D model of the installation, and this model could be also printed, or if you have in your configuration this IFC file export module, you can export it to IFC file. And I would like to supplement documentation of this project by schematic views of the installation. Schematic views are generated automatically. We need to just indicate starting point, and because I want to have schematic view of the whole installation, I will put the starting point on a source. This is that element. It should indicate just one element of the installation. So I will put it like this just to cover some part of the source. And you can see some data, symbol A, and more data, but we don't need to change them or check them now. And you need to just click on this button, generate. And after a few seconds, if you display this window, you will find another tree. There on the left side, we've got plan views. On the right side, we have schematic views. This is symbol A, like symbol of the starting point. And there you will see complete schematic view of this installation. So as you can see, we don't need to draw it parallelly to plan views because program will generate it automatically. And we can see all pipes, radiators, valves, settings, everything is created automatically. We may need introduce some corrections. For example, we may need to move some labels, or for example, we may add some labels on the risers. So generally this automatically generated schematic view can be processed to obtain final result, final drawings for printouts or for export. And by changing configuration of starting point, we may also control the scope of information presented on schematic view. For example, instead of creating the whole installation, we may just create schematic view of the installation in the basement and the risers. Or back we may generate again complete installation. And if anything is changed in the project, if you add more parts of the installation, more levels, and you click once again this button, program will draw the new part of installation. Okay, so now we have plan views, we have 3D view, and we have schematic views. And now let's go to the final stage. Let's prepare drawings for printout or just to export it to DWG file. Before we prepare a printout, let's take a look once again on one of the plan views and on labels you can find on it. For example, this is label of the radiator, this is label of the valve, and you can find some information. For example, we cannot see now any information about the pipes, and we can use some labels to add this information. So if you would like to have these pipes or some pipes labeled, you can just use this single icon and click on each pipe to insert labels, or you can select some pipes and use this icon, insert to all selected components. And you will find on each selected pipe run, just in the middle of this section, you will find this label. And this label provides some information about diameter and length of this section. For example, we can also rotate this label of this radiator and we can move it. But if you would like to change information displayed in any of these labels, you can do it in general data, and let's take one of examples. Let's change configuration of the label we have on the pipe runs. There in general data window we have component styles, and there are all items, all elements we can use in the project. And in this group heating cooling we should find pipe run. It's right there. And there you can see configuration or style of particular types of pipe runs. And if you want, you can also change it right here. And there in this window we have available configurations of label styles. And for example, let's change configuration or contents of the label on supply pipes. This is that one, what we have. And there you can see that there are more features that we can change. We can change the color, display or hide connecting line, change the shape of this line, change position of particular descriptions, font, and so on. But I will change only one feature of this label. Let's add more information, for example, mass flow rate. Mass flow rate, it will be displayed below in the next line with prefix and suffix. And when I click OK and switch back to 2D editing, now all the pipes that are placed on supply pipes, supply pipe runs, will get that additional information about mass flow rate. And this way you can flexibly control information displayed on a plan view or on a schematic view by changing configuration of label or of all elements that are presented on the drawings. And now finally we may go to the last stage, preparation of printouts. The view of the source was very poor, so I just changed it a little bit. I added more elements. There you will find different view of a source. Now it looks like a standing boiler with upper connection. We've got expansion vessel, and we've got more valves or fittings on the pipes. There are some shut-off valves, filter, and also there is some thermometer and pressure gauge. All these items you will find here. Some of them can be entered on the installation on the 3D view. Some are unavailable because you need to use 2D view to enter them on the drawing. So if you switch to 2D view, you will get access to all these elements. And let's take now one of the plan views and let's prepare it for printout. We need to change scope to printout, and first we need to put page layout. Now we have one page. I will change paper format to A3 and orientation of the paper to horizontal, and you can move this frame to fill it with installation or generally with the plan view. And there are more different parameters you can control for this page, like margins. You can also control what scope of your project will be printed on this page. For example, if you have in your project both cooling installation and heating installation, but also tap water installation, you can uncheck by clicking on these checkboxes some scopes from printout. And we may add here drawing chart. You can fill it by entering text in data table. And the same we should do with other plan views one by one, and also with schematic view. Maybe let's put there also one page. Change the scale. And let's also add here drawing chart. And if we prepare pages for printout, next we should look into printouts. And there you will find these pages we have just created. This is some part previously created, but probably this one will be this one we have just added. And you can just print it using your printout, or you can print it to PDF, or you can export it to one of these formats. So this is the first way. The next, instead of printing these drawings, we may export them to the DWG file. And in this window, you can control parameters of this result DWG files, how many separate DWG files will be created. By default, program proposes for each worksheet separate DWG file. If program detects that some of them were copied or they use common DWG file, export will be done to one result DWG file, and the schematic view will be presented on separate DWG file. And as I said, if this module is available in your configuration, you can also export model of the installation to IFC file and then process it in any other software compatible with BIM. So you can design other installation that is not available in our software, or you may just configure drawings and continue the project in some external software. Let's display the whole installation. So that's it for today. That's all what I wanted to show you in this tutorial. We have started with some ready building construction. We didn't create it from the beginning, but this you will find in other webinars or tutorials available on our YouTube channel. And we have just focused on hitting installation with radiators. We went through all the stages, starting from general data through graphical edition to results analysis and creation of schematic views. I hope you liked it, and I would like to thank you for your attention and also invite you to next tutorials we will record about other installations that you can design in InstalSystem 5 package. Thank you and bye bye.